So now we're going to look at some of the basic limit laws to help us with our calculations of limits. So the key thing about this theorem is that we are assuming initially that the limit of this function f of x and the limit of this function g of x as they both approach c exist. Now moving forward from that, we can then look at all the different laws that come from this. So the first law is the sum law. It basically says that if these two functions have limits and we are adding the two of them, we can actually split them up by parts. So I can take the limit of the first function plus the limit of the second function. Again, they're both approaching the same constant value c. For the second one, constant multiplication law, so k is any number, is a constant value, and they're saying that the limit when we multiply our function by k also exists. Therefore, if we can write it out as this, we can actually factor out that k, the constant value, out front of the function, and then worry about just taking the limit of this function, which we know exists. So it'll be k times the limit L. The product law basically says now that I've got these two functions multiplied together, this limit is going to exist as well, because we can now split it up into two parts. The limit of the first function as it approaches c multiplied by the limit of the second function as it approaches c. The quotient law is very similar. The one thing you do have to make sure is that the limit of your g of x is not equaling to 0, because then you would have a division by 0 and the limit would not exist. So this is very crucial that your g of x function, when you take the limit as you approach c, is not equal to 0. We can then split this function up again into the limit of f of x divided by the limit of g of x, like you see here. The next one is for powers and roots, and it's actually a very good, powerful law. When we have powers and roots, if you have any exponent that is applied to a function, we can then apply this exponent, assuming again that your q value is not 0, so you're not dividing by 0, we can apply the exponent to the entire limit of the basic function. Now I'm going to show you how this works in terms of an example with all of these different laws. Now this may seem quite straightforward. We could do this graphically, and we could do this using a table to see what the actual limit is as you approach 4. But now we can use the laws to simplify it a bit. So to start off with, we're going to break it down based on all these different laws. I'm going to use the sum law first. Now it says when you have two functions that are being added together, you can split them up into parts. So I'm going to write it as the limit as x approaches to 4 of x squared plus the limit as x approaches to 4 of 2x plus the limit as x approaches 4 of 1. So basically I've taken each of these parts as a function, f of x, g of x, h of x if you'd like. So that's just using your sum law. Then I'm going to look at each part. Now the first one, we have an exponent. So I'm going to use the powers and roots and write it as the limit as x approaches 4 of x, all raised to the power of 2. This just breaks it down so that my underlying function is just f of x equals x, which is easier to work with because last day we looked at two possible things when you're approaching a constant of k and the limit, as x is approaching c of x. So those are the two functions we looked at. This one equals c, this one equals k, the constant k and the variable x. So those are what we looked at last day. And now I can see that I've got a limit of x as x approaches 4. This is just going to equal 4 based on this portion right here. Now the second one here, so the first one used the powers and roots law. That was the first part. Now here we have a 2 multiplied by x. So we're going to use the constant multiplier rule. We can move the 2 out front and hence have the limit as x approaches to 4 of x. And again, I'm going to get the limit of x as x approaches 4. That's just going to become 4 based on this right here. Then my last one here is a limit of a constant, which we talked about last day. So limit of a constant equals k. So as x approaches c, it's still going to equal k. In this case, my k is 1. So I can then rewrite this portion right here, the limit of x as x approaches 4 is going to be 4. That's then going to be squared, plus 2 times, and again here the limit of x as x approaches 4 is just going to become 4, plus the limit of a constant is just going to be 1. So you'll have 4 times 4 is 16, plus 2 times 4 is 8, plus 1. So then I can write out my final entire thing. My limit as x is approaching 4 of x squared plus 2x minus 1 is equal to 25. And that uses all the limit laws. Now this is a straightforward example with a polynomial that I know has no holes in it, so it is a continuous function, which makes this kind of obvious. If I plugged in 4 into the original function, I would get 25. Now, these laws also come into play when we work with harder ones, ones that have non-permissible values, things that have division by zeros. So those ones are where these laws are really going to come into play, but we're going to start looking at some of the basic ones first, just to make sure you know how to use all the laws first.